I'm Anthony Burzillo. I work at Bloomberg. I am on the static analysis and automated refactoring team, so we're actually creating tools to basically fix code, find bugs, anything that we can do to make our code base better. So anyways, off we go. So basically, I have a couple goals for this talk. First of all, just kind of like let you guys know, what we're doing, what we've done, but also, I'm trying to bring up some pain points, and perhaps, no one's actually encountered these pain points, but more than likely, there's probably already existing solutions to these problems that we don't actually know about. So feel free to talk to me afterwards, and actually, I would love it if you would talk to me afterwards and show me the error of my ways, as it were. So basically, we're going to go through these topics. Basically, how do we use Haskell at Bloomberg? And then more specifically, like how we're actually using GHC, hackage, and stack in our own internal workflows. So here's an obligatory slide. So what is Bloomberg? In case you don't know, maybe you've seen the TV thing. But basically, we provide high-quality data to, a lot of people know that we provide data to finance. But we also provide it to government and legal institutions. So we actually have 119K employees at like 192 locations. And we actually have 5,500 software engineers. And we take about 120 market data points per day, but we've actually taken about 10 million at peak, which is quite a lot. My team doesn't deal with that. We are just dealing with code. But a lot of other teams are doing some pretty crazy stuff. I don't know if you can see this picture very well, but the undertitle is supposed to say at our Westeros office. Maybe I should have waited until the finale came out before I put this on the slide, but anyways, beyond that point. Okay, so how do we use Haskell? So basically, what we really do is we physically deploy Haskell to our physical machines using Debian. You might be familiar with this because it's like on Ubuntu. So if you've ever used like apt or apt-get, it's a pretty easy way to package things. It works out pretty well, pretty easy to specify dependencies and so forth. But what we actually use to build Haskell in our Debian system is Cabal. So we actually have our own internal hackage, which we call BB hackage, Bloomberg hackage. But basically, the reason that we do this is so we don't have to deal with proxies, because I don't know if probably most of you guys who work at like a reasonably large company, you probably have a lot of proxies because of compliance or other things like that. It's pretty annoying to have to deal with proxies all the time. So it's rather helpful to have it, internally mirrored. And it's also a lot faster to like download packages and other things like that. But we also store our own personal projects on our own internal hackage, which is pretty useful because it just makes it pretty easy to work with like either Stack or Cabal or whatever you're using to build your projects. So though we use Cabal and dpackage, we actually use Stack for our local development, and we've really found that Stack is really helpful for us because, especially with the LTS, which basically helps us so that we know we always have a consistent set of packages. We've been able to, keep everything consistent and always buildable and avoid, the dependency hell, which used to be around. But we actually have created our own LTS, which we call BB LTS. You'll probably find a lot of things in this presentation that start with BB. I wonder why. But anyways, the nice thing about our BB LTS is we can actually, add our own packages or our own internal things to it. If we find that there's some package that isn't in the upstream LTS, we could actually add it to our own LTS. Of course, it wouldn't have the same KTLO requirements, that would typically be in the Stack LTS. But, since we're the ones who are using it, sorry, is this kind of, there we go. Sorry about that. It kind of sounds like there's a little bit of feedback. Okay, that's better now. No, it's not. Hello? Hello? Is it working? No? It's working now? Okay. Sorry about that, guys. I'll just leave it on the table. How about that? So yeah, so we found that actually creating our own BBLTS has really helped us with our development because we can just do what we want much faster, and sometimes the LTS itself won't actually move at the pace that we want it to. But we generally try and keep up with the most recent LTSs. So I guess that this kind of, so specifically to maintain our BBLTS, we've created this internal tool that kind of automates this entire process, which we call the maintainer workbench. And basically the entire guts of this thing is this massive YAML file where we basically describe what we want in addition to our LTS, and it basically helps translate, things that are upstream into our own local language. So to touch on that a little bit more, we've basically built this on top of the already wonderful data that's provided by Cabal files. So unlike a lot of other open source, package kind of ecosystems, like one of the worst ones that can come to mind is probably like C projects or like C++ projects, which really don't have the concept of a package at all. Sure, they have the concept of libraries, but libraries are kind of added after the fact. But since in Haskell, we already have a pretty good concept of libraries, as well as like library dependencies and other things like that. And especially because it's so strict on like version requirements and other stuff like that, it makes it really easy to automate, which has been really nice for this automation thing that we've been doing. But basically, our workbench.yaml file is a bunch of different stuff. This is big enough, right? Can you guys see this? Cool. So one of the things is like we specify which LTS we need to use. Something that is actually pretty common is we'll actually need to rename dependencies. For instance, like if you consider like Fedora versus Ubuntu, if you've ever dealt with their package management systems, like Fedora uses Yum, and they have a very different package naming scheme than Ubuntu, which uses dpackage. And so one of the things that you often have to do is you have to actually, like in the Cabal file itself, it might specify like a package dependency like zlib, but that might not exist in your actual distribution. So we've created a method with this workbench to essentially rename those things automatically for us. So also, we have like extra packages that we want to include in our BBLTS that are included in this. Any external dependencies that we would need to actually build any of these packages, we also specify so we can ensure that they're available. And we have a blacklist, and the blacklist specifically would say anything that we don't need to pull in for various reasons. One of the things might be some package that's automatically already packaged with GHC, might be a system library or something like that. We don't want the automatic workbench to kind of go out trying to find something that already exists, right? So then with all of this information, basically we can use it to do various things automatically in our systems, like you can run it and automatically publish the BBLTS to our internal GitHub. So then you can actually access the BBLTS from stack. So you can specify like a URL that you'd want it to point to. You can also generate and publish all of the D packages, which is super cool because we're actually managing around 700 packages that we're publishing into our internal D package. So instead of us actually having to go in and update the new versions, put up the tars, various things like that, we can actually do that completely automatically, which is nice. And it's much harder to do with other languages. So we actually have like one of the best stories, I think, for being able to automate such a large-scale system. So yeah, basically it's really nice. And like I've tried to do similar things like this before, and it's never been as easy as with Haskell. So let's take a little closer look at how we're actually using some of the tools. So let's look at GHC first. So as I mentioned before, we're using the GHC that we've actually packaged internally. We actually always try and package the most recent version of GHC. And it didn't used to be this way. Previously, the GHC maintainers weren't really releasing things as quickly as they are now, but it's really nice that we're getting new updates all the time. And Stack is also keeping in pace with that. So we're getting all the great new features. So I really like to thank them for that. It's really helpful. But so one thing is it's actually it was kind of a huge pain to get GHC packaged. Now, if you're just using it locally on your machine, you might use something like on a Mac, what is that thing called? There's that packaging system, I forget what the name of it is right now. Yeah, Homebrew. So, you can brew install GHC, probably it works pretty well. Or if you're on Ubuntu, you can just, apt-get install it. So that's pretty nice, but you actually aren't really thinking about how you'd actually have to build it the first time. And it's actually pretty difficult because GHC actually builds itself. So if you're trying to get that thing to work from the beginning, it's kind of difficult. So we actually use a bunch of different OSs. So an example is like we use RHEL internally, which is Red Hat Enterprise Linux. We also use Ubuntu. And so if we're using Ubuntu, it's basically already packaged for us, which is nice. But we more commonly use RHEL. And we were actually using a pretty old version of RHEL for a while, which was RHEL 5. And we first started trying to package GHC back in 2015. So even back then, it was still pretty old. I don't know exactly when RHEL 5 came out, but I think even at that point, Red Hat Enterprise Linux 7 had been out, so we were 2 major versions behind on some of our machines. But we still had to support it. So like a common way that you might do something like this, like if you're trying to actually get a more modern version of GHC to work, and this is kind of universally true with any kind of depackage thing that you're trying to do, basically you'd package some older version of whatever you're trying to get working. And then you use that older version to build some newer version, and so on and so forth. The problem is that oftentimes there are like version incompatibilities, so maybe one version of GHC can't build a newer version. So you kind of have to make like steps in between, like, oh, I need version 3 to build 4, but 4 can't build 7, so I also need to package 6, so on and so forth. So you end up kind of with a chain of dependencies that you kind of have to build. So that's quite annoying. But since we were using our Red Hat Enterprise Linux 5, it actually had such an old version of glibc that we had to go way back to 6.12.3. And I think at the time, GHC was probably like in the later 7s. So this version actually came out in 2010. So we were actually packaging in 2015 something that had been originally published in 2010. And we eventually got it to work, but we had to find one that was actually compatible with our version of glibc. But if you kind of look at the chain that we had to do, we started with 16.12, then did 7.4, 7.8, and it doesn't fit on the slide. But eventually we're on the most recent version, which is nice. But it was quite a path. So yeah, don't worry, we don't use Red Hat Enterprise Linux 5 anymore. So the nice thing is now we're actually able to bootstrap from a much more recent version of the compiler. So instead of we don't use 16.12.3 at all anymore. But I don't remember exactly which one we're bootstrapping from now, but it's probably GHC 8. Okay, yeah. So that's nice. So we've removed that issue. But anyway, so this is one of the problems that we've encountered trying to get this to work in our depackage system. We've had to do quite a bootstrapping process. Another issue that we've had. So when we first started our effort, we originally were using a version of Debian where we didn't actually allow triggers. I don't know exactly why we were doing that, but I think for some reason that we thought people would probably do it in bad faith and would do things that they shouldn't probably be doing as triggers. So if you don't know what triggers are, they're different scripts that you can have run in the Debian process either before an install, maybe after an install. You could have it run before you remove something or after you remove something. So often, you're cleaning up things in the system. Maybe, you're talking with systemd or something to tell it to start a service for you or something like that, that you wouldn't want it to try and do it after you've removed the package, right? So you probably want these triggers. Well, the issue is with GHC, it actually has this package cache, which basically, I believe, keeps track of all the libraries you have installed on your system. Now, if you're typically doing this with like Cabal or like Stack, where you're actually installing stuff onto your computer, the typical way, it should always work because it'll always refresh the cache for you. But if you're trying to do something with depackage, for instance, it basically just deploys the thing straight to the location where it expects it to be. But it wouldn't actually be able to refresh the cache because you didn't have any of these triggers that you could run. So this was kind of a problem. We since enabled triggers because we've realized that we need them for various other things, example being like systemd. But the question still remains, is there maybe a better way to do this? I'm not sure. Possibly GHC could figure out if new libraries have been installed. I don't know if this would be horribly inefficient, though, because it probably would have to do it every time it ran. But anyways, that's one question I'm leaving up to you guys. Another thing. So Haskell's shared objects actually refer to each other and to other things with a relative path. So many times when you're using shared objects, you probably refer to things with an absolute path. The example being would be like if you link in the Linux shared objects, you probably would be using an absolute path to point to those .sos. But the Haskell shared objects actually point to each other in a relative way. So this is slightly annoying because the way that it will actually figure out what its actual path is by looking at proc. And if you don't know what proc is basically a description of all the processes that are running on the system. So one common thing that you might do is you can actually look at proc self, which would be your own process. And then you can figure out things like, okay, how was I actually invoked? Where am I? Like, where's my actual executable? I don't know if it has arguments in it, maybe it does. But there's a bunch of different information about your process. And so that would be where it's actually finding out its true path, and it would figure out relative paths from that. And actually, I believe that the actual loader that would be linking in your shared object actually uses proc as well. But anyways, we didn't originally have proc mounted because it didn't really seem like, why would you really need to be looking at your own process while you're trying to build something? But apparently, actually, a lot of things do use proc in their builds. So we were able to get around this by actually changing around the makefiles that GHC uses to build Haskell libraries. Basically preloading the location that we knew where they'd get installed, so it could easily figure out where it would have to put these paths. But it was quite annoying, and I'm sort of curious because I'm wondering if we really do need these relative paths. I realize that it makes relocating the shared objects a little bit easier, but perhaps you could do that when you're installing it. And or when you're building the SO, maybe we don't really need relocation. Maybe you could have that as an option or something. It would certainly make it a lot easier. We've actually since fixed this, so now we actually do Mountproc. And I think one of the main reasons we did that is because Java cannot build anything without proc being mounted because it uses proc for everything. It just will completely fail. And I don't even think it has a good error. It'll just fall over. So. Yeah, thank you, Java, I guess. Cool. So that was pretty much GHC. So now we'll talk a little bit about how we use hackage internally. So we use our own mirror of hackage, and basically we just pick up the files from the actual hackage itself. So we pretty much have a consistent view of exactly what is on the regular hackage. And it's actually funny, I kind of tested it out because I had actually uploaded something to hackage like 7 years ago. And I searched on our internal thing, and my package is actually there. So I thought that was kind of cool. So one thing that hackage does is they actually have revisions. And so the reason that this might be important is a lot of times people with their Cabal files, they might put version restrictions on what kind of versions they think people could potentially use. The thing is, oftentimes, a new major or even a new minor version wouldn't introduce incompatibilities with some, with however they're using the APIs. Sometimes these major and minors are only affecting small parts of the actual library's, visible API. So oftentimes these constraints are actually too specific, right? So the nice thing about revisions is that it actually allows you to go in and change, the Cabal file itself. So you could potentially make it, usable with a new minor or new major version of the package. The issue that we have with this is it's actually pretty difficult to mirror these revisions. I don't actually know how many other people have their own internal hackage set up, but the one issue we found is that we couldn't really get the versions to exactly match up with what we were seeing on the real hackage. So while one revision might be 4 on the upstream hackage, we might, for some reason, have it be version 20. The issue with that is Stack actually uses the revision number as part of the hash that it creates for these libraries. So then when you're actually trying to build something, it would actually fail to build because it was looking for a specific revision. And unfortunately, the revisions didn't match up because, it was looking for a specific hash. But unfortunately, the hashes didn't match up because the revision number was different. Now, it's possible we're doing something, slightly wrong, but maybe it's just really hard to do this, or maybe it's not really a use case that was much thought of. But we would love some help if anyone has been able to successfully do this. Yeah, basically what I talked about. So one other issue that we've run into is that with the documentation builder of hackage. Now this is super nice on the upstream hackage, right? You never actually have to build your documentation yourself. Basically, as long as you've written, okay, you of course have to still write your documentation yourself. But once you've written it, it should upload nicely to the upstream hackage. It'll build it for you, and you'll get the nice docs, basically, so people can see how your API can be used. Unfortunately, we haven't really been able to get this to work too well internally. And basically, what we found is that, in the background, it basically has a bunch of different workers that are building documentation for you. And they'll chug along for quite a while, building all your documentation just fine. But for some reason, every once in a while, one starts to hang. And then the other ones are still chugging along, but then another one starts to hang. And then eventually all your documentation builders are just stuck. We're not entirely sure why, but unfortunately we haven't really been able to get the documentation building to work, so we've actually shut it off. Fortunately though, the hackage actually provides a way for you to post the documentation to its website. So with our own internal tools we've developed to, for instance, like release new Haskell code, make sure it gets all through the ecosystem and stuff. We've actually been able to incorporate this documentation building and posting into our workflows. But it's still quite annoying because even though your own projects that you yourself are publishing might have their documentation uploaded, when you try and click a link to some other type, let's say, I don't know, in ASON or something, you'll find that the documentation for ASON isn't actually built on our internal hackage, which is quite annoying. And the issue is, potentially we could run a job to do this, but we're constantly getting new updates from hackage. So it's slightly annoying. We're kind of interested in ways that people think that we might be able to fortify this. Like maybe we could actually run the doc builders in Docker. Possibly, maybe there's some issue with the timeouts that we're not finding. Maybe there aren't actually timeout limits on how long documentation should be taking to build. I would assume that it probably would usually take about 2 hours for docs to build, but I don't know. There's probably some reasonable limit for how long the documentation should actually take to build. But that's one issue that we've run into. Another thing, so commonly when you're developing things and you're publishing into hackage, it's probably you and maybe one other person who's probably working on the project. So it's pretty easy to actually edit the maintainers, keep it up to date, so on and so forth. The issue that comes up is oftentimes you're actually working with a team of people. And if you've been working on a project for long enough, oftentimes that team changes. You might add someone, you might remove someone, so on and so forth. Unfortunately, if you have a significantly large amount of people who are on your team, it's pretty hard, especially when you have a new project, to go through the hackage and actually edit it repeatedly and add new people. And I think you actually have to do, I'm not sure if the page actually allows you to insert multiple people at the same time. I might be wrong about that. But it's quite a pain. So one thing that I'm proposing is it would be pretty cool if we had role-based permissioning in hackage, so this kind of management would be a lot easier. I'm not sure how useful this would be outside of industry, but I'm sure that there's some projects that are maintained by groups of people that would probably be helpful to have this sort of functionality. So that was basically how we're using hackage and things that we've run into. But we also use Stack for our local building needs, as I mentioned earlier. So we really, really like Stack. The dependencies of our builds always work together, as we mentioned. It's easy to replace packages with your local dependencies, which is actually super important for us because one thing that we want to make sure is like, if we're fixing a bug or we're adding a new feature, we want to make sure that the new stuff still works with the old stuff. So especially if you have some sort of continuous integration setup, it's really helpful to be able to specify, I want to use this package that's actually local and not some remote package that I would download. Easy integration with hackage, custom snapshots. Snapshots are super nice. So one issue that we've actually run into is it's actually pretty hard to configure your endpoints with Stack. We actually had to go in and modify the Stack executable to change where it was actually trying to pick up packages from. It actually has like AWS endpoint hard-coded into it. So yeah. So maybe there's a better way of doing this. I would assume that maybe there could be some configuration file. Sure, it could still be hard-coded to be AWS, but it would make it at least a little bit easier for us to change it. It also has GitHub specifically hard-coded. So maybe there's another way of saying, oh, we want to use a different endpoint for GitHub. But, because I don't want to have to patch everything. It's also snapshots. Snapshots are great. One thing that we've run into though is we would really, since we have our own internal set of packages, we would like them all to work together, right? And if we're building stuff locally, we probably always want to use the most recent versions of them. So one thing we originally looked into was trying to maintain snapshots for these, right? And you'd always keep the snapshot of the most recent versions of what you're trying to use, right? So let's say I publish a new version of package X. I want everyone to start using that immediately. I want all the tests to run against that new version, so on and so forth. So we thought about this for a while, and it seemed like snapshots were a good choice for this. So somehow we missed the memo that these were supposed to be immutable. We found this out. Yeah, actually Eric over there pointed it out. So because one of the things was I ran into this problem personally. I was running a new build, and I'm like, oh, it's clearly going to pick up this new version of this package that I just promoted, right? Unfortunately, no, because it actually only downloads a snapshot once because it assumes it's immutable. So basically, you might think that it would pick up the new thing, but it already assumes internally that these things will never change. The snapshots will never change, which is a reasonable assumption, I guess. So what we essentially originally envisioned doing was having this set of packages always being updated on some like endpoint, which we assumed it would kind of maybe get a hash of it or something and be like, oh, this thing's changed, but it clearly wasn't designed for that. And then the nice thing would be then we wouldn't actually have to modify the projects to get the new packages to be used because it would be the endpoint that would be modified. So we wouldn't actually have to touch the stack.yaml. So clearly that didn't work. So, one way of getting around this is just to delete your .stack every time, and probably your .stack work. But this is kind of a terrible idea if your projects take any kind of time to build. So, like if it's taking 20 minutes to build this one project, you probably don't want to delete the cache that you have of that thing already being built. So this was my first attempt to kind of fix the problem, but that didn't work. So yes, you can do a different thing. Definitely probably wrong, but another way you could get rid of this is by actually deleting the custom plan, which I guess is where it downloads all of your snapshots. And at this point, it would actually re-download the plan so you get the new versions of things. I'm not sure. Sometimes it's a little weird, though, because sometimes it actually does rebuild things when you didn't expect it, and sometimes it doesn't. But anyways, clearly this isn't a good solution either. So the only real correct way of doing this is to do something like the upstream stack does, where they have a new version for every change. But if you think about it from this internal thing where we're probably constantly releasing new things, this kind of gets hairy really quickly. We're actually on like the snapshot number like 80 or something like that. And the problem is, even if you're doing the right thing, right, and you constantly have your snapshot versions going up, you're constantly getting the new stuff, still somehow you have to get that into each one of your projects. Now the thing is, this isn't really an issue in the depackage world, of course, because we're using Cabal, so we'll always use the most recent version of anything that you have in that. But if you're trying to build stuff locally, you always have to remember, oh, I gotta check to see what's the new version of the snapshot. I gotta update my stack.yaml to point to that new snapshot. It gets pretty annoying. One way you could fix this is by actually having your CI or publishing system go in and change every single stack.yaml in every single one of your projects. But that would be honestly horrible. Because not only would you flood your entire commit history with basically useless information, but basically whenever someone's trying to make a new pull request, they probably have to rebase every single time. That's kind of annoying. So probably not the best way. So we think maybe it would be kind of cool if you had some way of specifying in your snapshot that this is meant to be immutable. Meant to be mutable. Maybe this isn't really possible, but it would certainly be helpful. Or maybe if there was some way of coming up with some concept of a distribution as opposed to a snapshot. Because I guess even in the name, a snapshot kind of means, it's taken once and never changed. I guess we probably should have thought more about the meaning of the word before we tried this. But it would certainly be nice if there was some way to have like a cohesive set of packages that you could refer to. So another thing. So Stack is great with caching. Usually it works pretty well. But there is some issues that I've at least encountered, and perhaps I'm once again doing this wrong, and I would love you to tell me that I am wrong. But so a trivial example is basically, so you can imagine you have these libraries here, right? So you have B, C, and A. They're all Haskell projects. A is some sort of library. It provides some functionality that's used by both B and C. So let's say you're updating A essentially, and you want to check that it still works with B and C. So you basically can just add, if you have them all, like cloned next to each other, you can say, I just want it to use A that's right next to me as my dependency as opposed to grabbing it from upstream. So cool. So then you try in building, and you test in B first. All the tests work. You're like, yes, that's really nice. But you also notice that it built A. That's kind of expected. You probably think it would build A at least once. Let's assume you had cleanly cloned these. But then you move to B, and you move to C, and you find that it builds A again. And now you're sort of wondering, I wonder what happened to the A that I built. So maybe the issue is that you probably should have built A first, and then maybe it wouldn't recache that. But sometimes it doesn't really seem to work out. I'm not sure why. Sometimes I find it rebuilding it. Maybe I'm accidentally touching something in A and it thinks it needs to rebuild. But this might not seem like a big deal for a small library, but if your library takes forever to build, this can really slow down things like your continuous integration processes or other things like that. So it would probably be nice if it were a little bit smarter about the caching. So one example is, maybe it could use some sort of like a Merkle tree or something to figure out a hash of the thing and stick that kind of build in some like maybe more global thing. Let's say another example might be, let's say you have 2 copies of A on your machine for some reason. One thing's referring to it over here, the other one's referring to another one over here, but they're technically still the same. Probably you shouldn't have 2 copies of things on your machine that are exactly the same and trying to build against them. But let's say you do. It might be kind of nice if it could figure out, hey, I've already built this thing somewhere, and then maybe some way of cleaning that. But I at least think it would be really nice to have slightly better caching. But cool. So in conclusion, we found that Haskell is amazingly easy to automate. Like we're really proud of what we've been able to do. And even with a very, very large number of packages, I guess this isn't technically that many packages, but it is still quite a good number. And it's really easy to automate, the changing, publishing, and the usage of this all at once. We've had some hiccups along the way. But we've found some solutions, probably not the most ideal solutions, but things that work for us. And perhaps there are better solutions that already exist. Or maybe, maybe someone will come up with a solution sometime in the future, and we'd love to know about it. But yeah, so basically, thanks for listening. Really appreciate it.